Hello students, let us continue the chapter Atomic Structure and Chemical Bonding. In this module, we are going to first of all start with some valence electrons, that is elements having more than one valency, that is variable valency, like copper, silver, mercury having 1 and 2 valencies, iron 2 and 3, tin 2 and 4, lead 2 and 4, phosphorus 3 and 5, sulfur 4 and 6 respectively. These valence electrons are actually variable in nature due to the vacant d orbitals that you're going to study in the higher classes. A neutral atom, when it loses an electron, forms a cation. When it gains electron, forms an anion. As you can see in the diagram, it shows the formation of cation and anion by losing and gaining of electrons. Now we are going to move on to the formation of cation. As we can see from the diagram, a cation is formed when a neutral atom loses 1, 2 or 3 electrons. Like aluminium over here is having 283 in its electronic configuration. It loses its 3 outermost electrons to form a cation. It is Al3 plus. Formation of anions. Anion are negatively charged ions are formed because of gain of 1 or more electrons. As you can see, the example being chloride ion, and we are seeing oxide ion also. The chloride ion is formed by the gaining of 1 electron, and oxide ion is formed by gaining of 2 electrons respectively. In the following diagram, the formation of chloride ion is given clearly. We can see that the chlorine atom was having 2, 8 and 7 as an electronic configuration, but it gains 1 electron to complete its octet and forms a chloride ion with a charge of -1. Moving on to a fact that cation is always smaller than atom, and an ion is always larger than the atom from which they are formed. Formation of ionic compounds. Compounds composed of cations and ions are called ionic compounds. They are usually a combination of a metal cation and a non-metal anion. For example, sodium chloride. Although they are composed of ions, ionic compounds are electrically neutral. The total positive charge of the cations is equal to the total negative charge of the anions, because of which the molecule becomes electrically neutral. As we are seeing in the formation of sodium chloride, 1 electron which was extra in a sodium atom is transferred in the chlorine atom to form Na plus and Cl minus, and the bond form is ionic bond. So ionic bond forms a salt because the compound formed, that is sodium chloride, is a salt. Here we see the formation of magnesium chloride, MgCl2. Now the properties of ionic compounds. They have high melting and boiling points, indicating that they are strong bonds. Most are crystalline solids at room temperature. Ions in a regular geometric pattern are found over here. They are hard and brittle. They conduct electricity when molten or dissolved in water. That is, they are electrolytic in nature. They can break into individual ions, and those ions conduct electricity. Now moving on to covalent bonding. A covalent bond is formed when two or more electrons of an atom, its outermost energy level, are shared by other atoms like chlorine molecule. In this bonding, a stable arrangement is achieved by sharing of electrons rather than transfer of electrons that we have seen in case of ionic bonding. Examples shown over here. Chlorine atom, as we can see, one electron each is being shared by two atoms, complete the octet, and water molecule also being shown. It also contains covalent bonding. There are some more examples of covalent bonding being shown over here. Carbon-carbon double bond, triple bonds. Oxygen is having double covalent bonding. It is sharing two pairs of electrons. Now some properties of covalent bonding. Electrons are shared over here, so no ions. Only non-metals present. They have low melting points. They have low boiling points. Normally gases in nature, and some liquids or solids at room temperature. They don't conduct electricity. It's a very important difference between covalent compound and ionic compound. They normally don't dissolve in water, except those compounds having polar covalent bond, which will be dealing in the later half of this module. These are some of the examples having covalent bonding: hydrogen molecule, fluorine molecule, carbon dioxide, and a molecule of ammonia, etc. Polar covalent bonds, they form because not all the atoms that share electrons attract them equally. That is, there is difference in electropositivity or electronegativity because of which electrons are pulled towards the atoms which are having more electronegativity in them. So the atoms which pull the electrons, they obtain partial negative charge, as is seen in the molecule of HBr, and the atom which loses develops a partial positive charge. So thereby a dipole is obtained. Covalent bonding can also occur between atoms of different non-metal saturated molecules of covalent bonding. As you can see, that Cl molecule, another example, a polar covalent bond. So thank you. With this we come to an end of the chapter.